Okay, in these last two lessons, we're going to be looking at compound interest. In simple interest, you only earn interest on the original principal. So let's suppose that you invest $1,000 at 2% for 1 year. Your interest on that, after a year, you would have your original $1,000, plus you would have this 2% interest. So that 2% times $1,000. So you'd get $1,000 plus 20 more dollars, and you would have $1,020. You get $20 a year interest. In fact, the simple interest formula is that your interest is the principal amount times the rate times the time. So what if you did it for 5 years? Your principal would be $1,000. Your rate would be 0.02 per year, and then times 5 years. Your interest would come out to be $100. So after 5 years, you would have $1,100. You're only going to get interest on that $1,000. Now, if you think about it, that's not necessarily really fair, because if the bank is keeping your money, the second year, you should probably get interest on the $1,020. And then the third year, you should have even more. So compound interest not only pays you interest on the amount you invest or your principal, it also pays you interest on the interest you have accrued. In other words, as the value goes up, you get interest on interest. Let me show you what that looks like. Just suppose you invest $1,000 principal into a certificate of deposit, which is a CD with a 5-year term that pays a 2% annual percentage rate. That's what we just did. The compounding period is 1 year. Now, if we had simple interest, remember, you would get your total amount would be the principal you invested plus PRT. That's your interest with simple interest. So it would be your $1,000, and this is sometimes written as P1 plus RT. So it would be your $1,000 plus your 2% interest times your 5 years. We leave it in for the 5. So 1,000, that's going to be 0.1 times 1.1, and that's that $1,100 that we talked about. That's not a great deal. So we're going to look at how compound interest is better. So it says, how much will you have in the account at the end of the first year, the second year? So here's what we start. We know that we will have $1,000 we put in plus 0.02 times $1,000, or $1,000 times 0.02. Another way you could write that is you could factor that 1,000 out, and it'd be 1.02. So that's going to be $1,020. Okay. Now, the way this works is the next year you're going to get interest on your interest. So if you put in an amount of 1,020, that's how much we're going to start with this time. That's our new principal. It will still get 1.02%. So 1,020 times 1.02 gives you $1,040.40. We get an extra 40 cents that we don't get with simple interest. That 40 cents is the interest on the $20. Now, I want to write this another way. This 1,020, that's what this is, can be written as 1,000 times 1.02, and then there's this 1.02 times 1.02 again. So another way of writing it is this was our principal is 1,000, that's the original amount, and then 1.02 squared. That gives us 1,040. All right, what about another year? Well, now we're going to have 1,040 and 40 cents, and that's going to earn that 2%. And that is going to be $1,061. If I round it, it's going to be 21 cents. Let's keep going. And I'm just going to round this to 21 cents. So you can see now we're $1.21. With simple interest, we were getting $20 a year. But with compound interest, we're getting a little bit more. Now, if I'm going to change color. If I take this 1,040, remember that is the same as this. So I would have 1,000 times 1.02 squared times 1.02 again. That's going to be 1,000 times 1.02 cubed. We're starting to see a pattern that the amount is equal to the principal times 1 plus the interest rate. In this case, the interest rate was 2% times n. R is the rate for a period. And n is going to equal the number of periods. So that's our compound interest formula. Okay. It says, using patterns discovered in answer 2, develop an equation for the total amount accrued in a CD with an annual compounding after n years if the principal is $1,000 and the annual percentage rate is 2%. So we know that amount is going to be the principal amount, 1 plus the interest rate times the number of years or the number of compounding periods. So our principal was 1,000. Our rate was 2%, 0.02, and we're going to have 10 compounding periods. So these need to agree. R is a yearly rate, so N is the number of years. It is possible to do this where you have a monthly rate, and N would be the number of months. So it doesn't have to be years, but they do have to agree. So in this case, it's going to be 1,000, 1.02 to the 10th power. So 1,000 times 1.02 to the 10th power and I get $1,218.99. Now, with simple interest, I was getting $20 a year, Simple interest, I would have gotten $1,200. So it doesn't look like a huge difference, but it can really make a big difference over time. More compounding. We want to look at the characteristics of exponential growth, and we want to be able to use our compound interest formula for different compounding periods. Suppose you invest $1,000 in a 2-year CD with an annual percentage rate of 6%, where compounding occurs monthly. So we're going to go to a monthly rate. 6% interest yearly. What's the monthly rate? Well, there's 12 months. That's going to be 0.5% per month. If we make that a decimal, that is 0.005. Over the 2-year term of the CD, how many times will the bank pay you interest? Well, that is going to be 24 compounding periods. If I use that formula that we just had, that's the amount is the principal times 1 plus the rate to the nth power, we now have to realize that we need a monthly rate here and the number of months here. So this would be $1,000 invested, 1 plus 0.005, so a much smaller amount because it's every month, but we're going to do it 24 times in a 2-year period. So let's see what that gives us. Remember, the original simple interest was just going to pay $20 a year. It would have been $40. This is going to be a little bit more. A lot more. This came out to be $11.27.16. The more frequently you compound, the more money you will earn. That's a lot more than just $1,040. So frequent compounding, of course, this was also a higher rate. It was at 6%, not 2%. So a 6% rate is substantially better. That would have been $120. But even so, the fact that we're compounding monthly increases our return. It says use your answers to questions 1 and 2 to complete the table, the following table. Use the middle column to record how you found the results. So we know that we start with $1,000 and we're going to have our interest is 0.005 because that's 6% divided by 12. We're going to get a monthly rate per month. And if we only do it for 1 month, then after 1 month, we will have $1,005. We won't have any change. If we do this for 2 months, we will end up with $1,010 and 0.025. I'm not going to round. The bank doesn't really round till the very end. Notice instead of just getting $5 interest, we got a little bit over $5. Each time we have more compounding periods, but this is 1 plus that monthly rate. So for 3 months, and again, we're going to get more than just the $5 we started with. Just like 0.075 and a little change. By the time we do this for 6 months, we will get $1,030.38. I'm going to round to the nearest penny. Again, this was our principal, 0.005 was our rate, and 6 was the number of periods. So our basic formula is your final amount is your principal, 1 plus the rate times the number of compounding periods. If it's a yearly rate, it's the number of years. If it's a monthly rate, it must be the number of months. I think we've already done this. A equals P, 1 plus R to the N. A is your final amount. P is your principal. That's the amount that you invested. N is the rate. Could be a yearly, could be monthly, could be weekly, could be daily. And, I'm sorry, R is the rate. R is equal to the rate. And N is equal to the number of compounding periods. That has to agree with the rate. If we have a yearly rate, then we need, well, really we have to go by, if we are compounding yearly, we'll need a yearly rate. If we're compounding monthly, we need a monthly rate. So we have to make sure our rate agrees with the compounding period, how often they're going to compound. If compounding is done more often, what happens to the accumulated amount? It grows more quickly. The more frequently you compound, the more quickly your investment will grow. All right, that concludes this last lesson. Hopefully this will help you be successful with your homework.